once again, it is me, Brandon Hart, the Eco-Struder, and boy am I eco-cited to talk to you about some eco-friendly 3D printing filament. PHA. What the heck is it, Edgar? Let's find out together on this episode of the Eco-Struder. Our journey began back in 2015 when Brandon Hart, a young and naive 3D printing enthusiast, was on the search for eco-friendly, biodegradable, compostable 3D printer filaments. Surely such a thing must exist. Surely there must be multiple options out there with all sorts of fun colors and characteristics and features to them. Not really. It's commonly misunderstood that PLA, the most common 3D printer filament on the market today, is biodegradable? It's not. I'm sorry. It is a biofilament. It is a bio-based, bio-derived polymer. It's a biopolymer. All of these things make it sound super, super eco-friendly, and certainly it is better than a petroleum-based product. However, just because something comes from plants doesn't mean that it can very easily turn back into them. And that is where we find ourselves today. Most people think that PLA is fully biodegradable. You can toss it in your garbage can, feel good about it going into the landfill because it's just going to turn into dirt that children can play on at some point in the future. Sadly, that is not the reality of it. PLA can biodegrade, but much like most materials that are considered to be biodegradable, they're only going to biodegrade, meaning they're going to break down into their constituent parts. They're going to turn into things like carbon dioxide and oxygen and so on, if they are placed in a very specific set of conditions. Generally speaking, an industrial biodegradable facility, an industrial composter of some kind. You're not going to toss it into your backyard compost heap and expect everything to break down. Such is the way of the world, unfortunately. I'm curious, would you be interested in doing an episode focused on the idea of biodegradable versus compostable and how all of this plays out? I'd certainly be interested in doing that if you guys would want that. Throw your thoughts in the comments below and maybe we'll do an episode like that in the future. Anyway, I don't want to dwell on that too much right now because we have in front of us a selection of materials with one important ingredient, and that is this plastic known as PHA. What is PHA? Glad you asked, because I have my notes right here. I will certainly not remember how to say this otherwise. It is polyhydroxyalkanoates. Nailed it. That's definitely exactly how you say that. But basically PHA is another bioplastic. The big difference with PHA is that it does not require a specific set of environmental conditions in order to break down and biodegrade and essentially leave no microplastics in the environment. So that's really the holy grail. That's what we want as a bunch of tree-hugging hippie nerds that love 3D printing, such as this one. So how do we get that? Are there options out there? Well, we went on a search for as much PHA-based filament as we could find, and it's pretty much all right here in front of us. So I'd like to talk to you about these different options, and then the one that kind of steals the show, if you will. So first of all, we have the go-to option that everybody seems to point to. Certainly the most popular PLA PHA blend out there in the world is ColorFab's PLA PHA. They don't come up with a fancy, clever marketing name for it. It's just straight up PLA PHA. So this is a blend of PLA and PHA, as the name implies. But basically what you end up with is a pretty much PLA looking, acting, behaving type of material that is more biodegradable, Certainly the PHA aspect of it will be biodegradable and will break down in the environment without leaving behind a lot. However, we're still talking about something that has to go into an industrial composting facility before it's truly going to break down. And then you still have the PLA content that's left over. I was unable to locate exactly what sort of percentage we're talking about in terms of what's PLA versus what's PHA. It certainly prints like it's just straight up PLA, and it's very rigid as well, just like PLA tends to be. So I'd venture a guess that there's not a lot of PHA content in this particular material. However, having some is better than having none. So this is ColorFab's PLA PHA. Seems to print great. We're going to test it and see how impact resistant it is. That's why we have our lattice cubes here. But the next one I want to talk about is 3D Print Life's PLA, which I don't actually have. So we're going to pretend that this is 3D Print Life's PLA. Here we go. PLA PHA, or PLA as they call it, playing on the name, is essentially the same sort of thing. This is a material that is a PLA and PHA blend. Put together, you get a more eco-friendly material from the two, but it is still something that is going to require an industrial composting facility from all I can tell. We have printed with this before, as you saw in our Tough PLA video. If you haven't seen that video, the link is around here somewhere to take you to that video so you can check it out. But the PLA material is very much like PLA again, so I think it's a minimal PHA content combined with quite a bit of PLA. The one over here to my far right is a material from a startup called Goo Ventures. They call their material goo. So this is original goo in the original buttermilk color from Goo Ventures. And this material has a significantly higher percentage of PHA than what you find in the other two here. This material does not behave like PLA. It is quite a bit softer. It's got more of a silky, smooth feel to it. And there's a lot of stringing with this material. It just doesn't behave like a normal PLA does. You can see sort of the top layers aren't always that great with this particular material, but it does print, and we can print decent sized objects. Here's a Flexi Rex printed in the goo as well. It's pretty cool stuff. It is quite a bit warpier than either of these because, again, it's not acting like straight up PLA anymore. This, unfortunately, is no longer an option from most places. We still have some of it at HeartSmart Products, and it's available for sale on our website, but this is really a material from a company who started up with the idea of trying to find the best bioplastics that they possibly can to make a high-performing PLA PHA blend that is the lowest impact on the environment that they could come up with. And they were well on their way to doing it, and it just seems like things didn't quite work out for the company, so they are no longer making this material. However, if you can find it, it's fun to print with. It's kind of cool stuff. Follow their printing instructions very carefully because it can be a challenge and it can warp up quite a bit during printing if you don't have a good bed adhesive or if you have your bed temperature set too high. Okay, that's a whole lot of talk about the alternatives, but we really got to get to the star of the show over here, and that is a brand new material from ColorFab. In addition to their PLA PHA, they now have a material known as Alpha, or all PHA. You want to guess how much of this material is PHA? It's all of it. It's Alpha, all PHA. It's a fun marketing name. So yes, this Alpha material is brand new. We actually pre-ordered it before they were even offering it so that we could get our hands on it. This did not exist when the idea for this video was established. We wanted to find the best PHA based materials that we could in order to make a video about some cool, more biodegradable types of options for our viewers out there. But then all of a sudden this was announced, and what great timing. So we had to get some. We got the black Alpha. It comes on a cardboard spool, and it is 750 grams of material on the spool, and comes in a nice box like this right here, directly from the Netherlands. So how does it compare to the materials we've already tested, which are a combination of PLA and PHA? Well, first of all, when you print with this material, you are printing with a pure PHA material, which means that the more biodegradable aspects of all these other materials is all you're printing with here. So yeah, this material fully biodegrades, 100%. The statement from Color Fab is Alpha is 100% bio-based and 100% biodegradable in any biotope. That's important. That means that you don't have to put it into an industrial composting facility for it to break down and return to its constituent parts, and as they say here, without leaving any microplastics in the environment. That is awesome. I mean, wow, we finally have something that lives up to the hype of being a biodegradable material. This is super, super cool. So, how does it print? How does it work? Well, I wish it was all sunshine and butterflies, but sadly it is not. We had quite a bit of failures when printing with this particular material. This was printed on the Sidewinder X2. We recently, we have an upcoming video about that particular machine if you're interested in that. But this machine is capable of printing, very decent looking parts. But our experience is that you tend to get a lot of scrap when you first start printing with this particular material. And that's due to a variety of different things. Number one, the material itself is softer than a lot of other materials. It's very flexible compared to a PLA. You can essentially bend it and flex it, and the fatigue resistance is not terribly high, such that it will break off in your hands if you do that enough. So it's a material that is soft, but it's also not terribly robust, if you will. It's not brittle, but it will kind of wear out a little bit over time. So it also has the unique aspect of needing to print on a cold bed. So if you happen to have a machine that does not have a heated bed, guess what? This material is great because it does not want any heat on the bed whatsoever, or parts will warp up. You also need to print with some sort of bed adhesive, Magigoo, Demafix, 3D Lac, Easy Fix, whatever the case may be. We've also tried using just straight up school glue, for example, on the goo, and it works kind of okay-ish, but you got to have some sort of bed adhesive. Also, whether you do a full brim or you do just the adhesive, the Mickey Mouse ears I call them, anti-warping discs, is up to you, but you have to have some way of kind of holding the part down. You may be sensing sort of a pattern here, which is that it likes to warp up off of the bed if you're not careful. However, if you are careful and you do it right, you can end up with some very nice printed parts, and it does work quite well. So, these things can work out quite well if you dial in your print settings just perfectly. We printed a couple of lattice cubes because this material has interesting flexibility to it, and we thought, well, maybe that makes it pretty impact resistant. Be curious to find out. Actually, let's find out. Let's smash these lattice cubes and see what happens. All right, we have our familiar setup here for testing impact resistance on different materials. So we're gonna jump right into dropping the ball and seeing if any of these manufacturers drop the ball on their impact resistance. First off, we have ColorFab's PLA PHA. Let's give this a try. Okay, well, I don't know if we call that a fail. It did survive the initial impact, so I think we're okay. Right now we are at 30 centimeters or 300 millimeters. I feel like it's pretty low, and most materials should be able to survive this kind of an impact, but we'll see. All right, and now we're gonna move on to Goo Ventures. There we go. And of course, Alpha. No problem at all. Just shrugs it off. All right, let's move up to, let's go all the way up to 400 millimeters. Okay, dropping again at 400 millimeters. Whew. I'd say that's a pass. We are joined by our trusty lab assistant, Kaladin Korgblest, here. Thank you, Cal, for joining us. Ooh, that's gonna be a fail. Very crunchy. Oh, that's a fail on the Goo Ventures. Let's give them one more try to survive this height before fully disqualifying them. Yeah, that would be a smash. Goo Ventures is out at 400 millimeters. Alpha. No problem at all. As suspected, the increased flexibility allows the material to deform a little bit and absorb the impact rather than just breaking. So that could be a good reason to use this material. Right, Cal? Awesome. Moving up to 500 millimeters. All right, once again at 500 millimeters. The stress was too much for Cal, so he left us. Here we go. Oh, that's a crunch right there. Yikes. All right, let's give it one more shot. Actually, that worked. I'm gonna give it a pass. Okay, well, it kind of didn't think that would happen. That's the fun of experimentation. Okay, now the Alpha. No problem at all. Well, you know what's next? 600 millimeters. Okay, ColorFab PLA PHA at 600 millimeters. Okay, there's no denying that. That's a fail. Sorry, ColorFab. And then there was one. We have the Alpha. .600 millimeters, ColorFab Alpha. And we have a fail. Let's try it one more time, just in case the previous sample had started to break down from previous hits. It broke. Okay, so I would say in general, the ColorFab Alpha definitely did take more of an impact before failure than most of the ones that have PLA and PHA. So, very interesting. Back to the desk. Well, that was interesting. So yeah, actually the materials that have less PLA in them, AKA no PLA in them, actually can take more of an impact. Certainly doesn't make it impervious to impact, but it will be able to take more of a hit. So that PHA, being as flexible as it is able to absorb those impacts and therefore be able to survive more of them. So that could be an interesting point with the alpha material. Okay, so we have to kind of address the elephant in the room, which is, how much does it cost? This is all great. It's great that it breaks down in nature. It's great that it doesn't leave behind any microplastics. It's great that it can print okay. If you put a brim on it, print it cold, and set your nozzle to 200C. But how much does it cost? Is it practical to use this material? Well, it's $49 for a 750 gram spool. Now, wait. Don't turn the video off yet. You have to keep in mind that this is a material that is brand new. There is nobody else making it, as far as I'm aware. And it is a material that I imagine, as they perfect the process, as the supply of material, resins to put into the process, improves. I'm hoping that price will come down as more and more people know about alpha and start buying alpha. They can make it in larger quantities, maybe make even more colors. I'm hoping that price comes down, but as of right now, as of the recording of this video, it is a little bit expensive for the material that you get. So then that begs the question, who is this for? It's a great material and everything, but like, who's this for? Who would buy this? Why would they buy this? Well, certainly, dirty granola eating, tree hugging hippies like myself love this type of thing. And if I can print parts with this particular material that I know are not going to exist for 500 and some years in a landfill, then I'm gonna do that. So certainly I'm gonna reach for this whenever possible. Yes, it's expensive. You wouldn't want to print extraordinarily large things with this material, but given its flexibility and its impact resistance, there could be some situations where you want something that is less rigid than a typical PLA is, in which case the material properties of this are better than perhaps reaching for a nylon or reaching for some sort of a rigid TPU, both of which are petroleum based and will exist almost forever. So it's for people who care about the environment. Clearly, it is a material that has a bit of a price tag associated with it that I hope will come down over time. But it is a very, very interesting innovation, and I applaud the folks at ColorFab for going this direction and coming up with a product that is actually printable and fully biodegradable without special facilities. Awesome stuff. I will leave links to data sheets in the description, so if you want to check out any of these materials, you can do that. Not all of them have data sheets, but in those cases I'll direct you to wherever I can so that you can get some more information on each material. All in all, PHA seems to be a new material to the 3D printer market that has a lot of potential. Hopefully, as the popularity of this material, either as an additive to existing materials or as a standalone material, as that popularity grows, so will the available options, and in an inverse relationship, so will the price will drop as well. That's my hope. So with that, I just want to say thank you very much for watching. If you made it all the way to the end of this big, long, rambling part, then I really do appreciate that, and would love it if you would leave a like, hit the subscribe button if you haven't already, and let me know what other eco-friendly materials have you found? What other materials that claim to be biodegradable, compostable, would you like us to test? Would you want us to look into and report back on? This is the kind of stuff that is near and dear to my heart, so I am open to all suggestions. With that being said, I want to wish everybody a wonderful remainder of 2022 and whatever year you happen to be watching this in, and have fun printing. We'll see you next time.